You have a Mac M1. You can try this one. I just tried it today. This video, I'll take away. That video is from another project. But the point here is you can compile on Windows ARM code now. This is all very new. Like I say, you have to have the very latest version of Fusion to run Windows 11 on ARM. And you have to have the very latest version of Visual Studio. And you will be able to compile ARM code. So you install Visual Studio with desktop development with C++. And when you get it, when you click your Start All Programs, you'll find in Visual Studio an ARM Native Tools command prompt. And if you go in there, you can now compile code. So I made a little program in C++, which has a password that's not terribly obvious. It has an encoded password, and it decodes the password and compares it to the one you type in. And so that's you compile it like this. The EHSC, it requires, for some reason, I didn't really understand it. The ZI stores symbols when it compiles, so it's easier to debug. And that creates a program called secret.exe, where you enter the password, and it'll tell you fail unless you get it right. And so the way you can identify ARM code in Windows is you look at the properties of the executable, and then in the compatibility tab, you could try to make it run on ARM, but here it's all grayed out. If all this stuff is grayed out, it's native ARM code. That is a pretty weird indirect clue, but that's the clue that you have a native ARM code. And you can view the ARM code by installing WinDebug. Some of the other projects that are older refer to this thing called WinDebug Preview. It is now no longer a preview. You can download it in Edge, and you get this new version of Microsoft WinDebug, and this can debug ARM. So this is what WinDebug looks like. It's a little bit like Ollie. It's a whole lot less friendly. And you can now debug that file. When you load it, it will show you the modules that loaded. So secret ran, and when secret loaded, it had to load these libraries. So these are the components that are put together to make this little program. Now, you can search for secret's main routine this way and put a breakpoint at secret's main routine, and G will run to the breakpoint. This is one thing very annoying about all debugging. When you get to a program's starting point, it's typically not any of the code you wrote. It's some kind of library that's used to load the code you wrote. You have to somehow get it to proceed to the code you wrote, and this is one way to do it. So now it loads. This is a source code debugger because I compiled with the XI switch, so you can see the source code. So here we are at the main and a breakpoint, and now you can view the disassembly view. And here's what the ARM code looks like. STP move BL is a branch, subtract, add string. You see it's kind of like IntelliAssembly code, but it's somewhat different. And this is the main code. This is the compiled ARM code. And if you return to source view, you can, in this particular program, it's going to take an encoded password, it's going to decode it, and then it's going to compare it to what you typed in. So if you stop at this point, it has finished decoding the password, and you can find out the password by examining the contents of the PWD variable at this point. And that's what you can do in the debugger. You can put a breakpoint here and run to the debugger, and then the password will be visible here as the contents of the PWD variable. So this is a simple example of the good stuff you can do with the debugger. And anyway, but you can only do it if you have a Mac M1. And so I wanted to show you that. And therefore it's extra credit, of course, because not everybody can do it. And that's all I wanted to show you tonight.